Alright, so now you're probably thinking, whoa, Shamar, you hit it at the same power. That's impossible. How come you went further the first time? Well, you could say I just tilted my racket and then made it point down. But no, that's not what I did. I kept the racket at the same tilt. I'll tell you exactly what I did. So you got the tennis ball, right? And it goes this direction. It goes boom, boom. So naturally, it should go straight ahead. It should just go straight. That's it. Okay? But no. This is what's called a flat ball. That's a flat ball. But that's not what I did the second video. That's what I did the first video where I just hit it flat. Okay. Now, the second video, what I did. So you got your tennis ball, and I did this because I'm very experienced and I'm super good at tennis. Don't research it. It's a fact. It's a known fact, all right? So you got boom, boom, boom. You got a tennis ball, all right? What I did was I sliced my racket so that the ball was spinning. The ball spun in this direction, just like that. And this caused it to go boom, 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 and down. It made it go down because that's what it does because of the air pressure around it. It creates the air. So before, as I demonstrated, it went like this with the flat ball. But instead, what I did this time was the air, since the ball was spinning in this direction, the air was also spinning in this direction, and it was just pushing it down, if that makes sense. Especially because gravity's pushing the ball down this way. The ball would just go boom, and then it would go boom. And this would just shoom, like an escalator, I guess, except it points the ball down. So, now you're probably wondering, hey, Shamar, what's the formula, partner? And I'll tell you exactly what's the formula. CL equals 1/2 brackets, because those are very important. 2 plus parenthesis V/V, boom, and then brackets again. Alright, now, Shamar, why is this important? I'll tell you. Wait, that looks like a V. This is a 1/. Sorry, my handwriting is pretty bad. Yeet. Okay, now, Shamar, what do these even mean? I've never seen these before. I'll tell you a little secret. I've never seen these before until like last week or something. And I spent all this time trying to research it, and I did the most I could. So basically what we're looking here is for CL. CL is the lift coefficient. So basically how much it goes up or how much it goes down. Based on how far it goes or how much it spins, and etc., etc. There's a lot of components. Every time you run into one situation, it asks for another answer. Then you got V/V, which is pretty difficult to determine if you're the one that wanted to measure exactly how much your average spins are, because you would need a slow-mo camera and find out exactly how much it spins. That's because that's how much the ball spins. V/V is how much the ball spins. So 1 revolution per second equals 6.28. What does it equal 6.28? No idea, but it equals 6.28 of something. So, say for example, if your ball were to figure out go 20 revs per second, then you would convert that into the 6.28. Oh, radians. It's called radians. 6.28 radians. And then you find out how many radians 20 revs per second is. That's for the V/V part of this formula right here. However, I had some trouble along the way trying to figure out exactly how to use this formula. Not in, oh wow, Shamar, you're so dumb, you just put in the numbers. That's because I couldn't figure out exactly how much the lift coefficient answer would be. So like, how much would it go? How fast would you determine how how much did it go down, or how much did it go up, or how long did it take to go 2 feet, 4 feet? I couldn't figure that out. I did as much research as possible. The furthest I got was finding out that what these right here, Hanit, were. But good news, I'm taking physics next year, and these will all be like the back of my hand to me. So yippee, 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 yippee. Yep. Watch. You'll see.